say we can't minimize it and use it only when it's absolutely necessary and absolutely required, and when there's no other alternative. So I'm looking forward to a world where all the science that can be done on things that are not live animals are done, and then we only use the live animals for the studies in between that discovery research and the clinical trials. Right? There's a place where live animals have to occur. And if we can, get everything to the point where we only do experiments on those subset of, particular needs, then I think that would be the best that we could do.
But specifically in modeling pain, I'm sure that there could be other computer things that you could do, like but you're saying for your field, you'll never see
again, I just don't know. How do you program something to react in a way that a biological system does before you understand how the biological system works?
That's true.
I just don't see how that program would be created. We
have a gentleman who's coming on the show in August. He has the gentleman that mapped out the fly brain. So they had all these neurons and points and stuff. Joshua Fogelstein. He somehow took a computer and aggregated all the data points and was able to map it out. And so I thought, this is promising.
I agree. It's very promising. Remember, though, that the fly people have major advantages over us mammalian people, right? The fly brain, we know every neuron, we know how it developed, we know where it came from, we know how it migrated to where it ends up. Like, we've mapped that all out. But that's just, a few thousand neurons and a few million connections. A mammalian brain is, hundreds of billions of neurons and quadrillions of connections. We're not even close. I'm not sure there's a computer. If you had a computer the size of the universe, I'm not sure you'd be able to model a mammalian brain. That's how many connections we're talking about, right?
I'm going to find a technologist who can confirm that. Okay. But
look, in the long run, who knows what the future will bring? Again, I'm talking about the medium term here.
Right. I would hate to predict the future because I know I'd probably be wrong. So other than that, speaking about technology, AI, everybody's talking about AI. Is there any part of your work that you're using to, put together data, anything? Are colleagues talking about it?
Yeah, AI is obviously incredibly useful. It has been for quite some time. In our personal experience, where we've used AI is we developed a way to measure pain in animals based on facial expression called grimace scales. And grimace scales work great. The problem is they're a lot of work. And because they're a lot of work, people don't want to use them because, they'd rather use the easier methods than the harder methods. But we said to ourselves, well, if we can train ourselves to see what a mouse in pain's face looks like, surely an AI can learn how to do it. And indeed, it can. And so we, in collaboration with a colleague at University of North Carolina, have trained a machine learning algorithm to do just that. It's freely available on the web right now. And so, yeah, computers can tell whether mice are in pain just as well as we can.
Wow. And then you had a publication, the development of the validation of pain face. That was
Yes, exactly. That's the name of the system. It's called painface.net. And it works. Now, it's very finicky. The lighting has to be just so, and the mice has to be positioned just so. But it really, really works if you set it up right. And of course, as the algorithm is trained by more and more people using it, it will get more robust. And it will become more accurate and more forgiving of circumstances that don't exactly line up the way it was trained.
Have you seen it improve since its inception? Speaking about it teaching itself, yeah?
Oh, yeah. It gets accurate with every iteration. Like every version they make, we see it get better. Yeah.
So what are we looking for? Are there characteristics that you can explain about a mouse grimace?
Oh, yeah. So there's 5 things that happen. So the first will not be of any surprise to anyone. The eyes get squinty. And I should mention that the idea for the mouse grimace scale came directly from the scale they use for babies. Okay, so babies obviously can't tell you how much pain they're in. And so people can quantify pain in babies based on facial expression. And we just took the baby scale and we adapted it. It's so obvious that it's amazing it took that long for anyone to think of it as an idea. Because Darwin himself wrote a book in 1872 that pointed out that all facial expressions in humans are found in all mammals, right? So squinty eyes, the cheek bulges, the nose bulges, the ears change their position. Obviously, that doesn't happen in babies because they can't move their ears. And then finally, the whiskers change their position too. Again, if babies had whiskers, I'm sure they'd do it. And it's those 5 things. And you basically, you look at a photograph of the animal, and you can easily be trained. I could train you in a half an hour, I'm sure, to be 75, 80% accurate, telling me whether a mouse is or isn't in pain.
And so what are the implications of all this study, like as far as a grimacing mouse? What does that tell you about the future of the preclinical pain research?
It solves a big problem we had in the field, which is this. The number one symptom of pain clinically in humans is what we call spontaneous pain. My arm hurts, my leg hurts. Nothing needs to touch it. I don't need to move it. I can be lying on a bed and the body part hurts. Okay. That is, overwhelmingly present in chronic pain sufferers. It's the thing they complain about most. That's not what we measure in animals. What we measure in animals is of what we call evoked hypersensitivity, which basically is tenderness to touch, or you can also do it with heat or cold stimuli. So what we do is we take a body part and we poke at it, either with a fiber or with a heat beam or with ice, and we look at the withdrawal of the mouse that gets faster. Okay. But the problem with that is that although that's a real symptom of human clinical pain, it's not a big one. And so what I've been arguing for years, and others in the field as well, is we need to start measuring spontaneous pain in animals and stop only measuring this evoked hypersensitivity. But no one's really had a good way of doing that. Grimacing, facial expression, is a way to solve this problem. You put an animal in a box, there's a video camera on it, the experimenter isn't even in the room, we're not touching the mouse, we're not doing anything to it, we're not bothering it, we're not stressing it, we're not even there. And then we or a computer scores the facial expressions later. And so the nice thing about this, the real advance here, is that we're finally able to measure the type of pain that we really should be measuring in animals, instead of something that's close but not really the real deal.
And you think if we ran this algorithm on humans that you might get similar kind of results? Oh,
we already know. I mean, this is done in babies all the time, and it's highly accurate.
If my whiskers go up, then that means...
obviously the baby scale doesn't have the whiskers and the ears, but yeah, the baby version of this is highly accurate. This has been done on older adults with dementia as well. Facial expression as a measure of pain is a well-validated way to go about it.
That's wild. So I obviously this is all not just for kicks, where we're trying to get to the bottom of pain and the way it works. So what is in your mind kind of the end goal for this kind of research?
Well, as I mentioned at the top, in terms of prevalence, in terms of total disability, chronic pain is the biggest health problem in the world. People don't realize that, but that's because there are different things with different names, and people don't put them together and realize that they're all chronic pain. But if you imagine how many people in the world have low back pain or arthritis or headaches, or neck and shoulder pain, and you put that all together, you realize that's a lot of people. In fact, that's 20 to 25% of the population at any one time, and 50% of the population in a lifetime. So your chance before you die of having chronic pain, which is pain that lasts 3 months or longer, is 1 in 2. That's way bigger than every other health problem in terms of prevalence. And it costs more money to society than every other health problem. The only thing that comes close is depression. So it's a big problem, and we're really bad at treating it. So we're very good at treating acute pain. If the pain isn't that bad, over-the-counter drugs like ibuprofen work pretty well. If the pain is bad in an acute sense, opioids work very well. Right? If you fracture your, femur, that's the drug you want, believe me, and it works amazing. But for chronic pain, we have a real problem because opioids don't generally work very well for chronic pain, and neither does anything else, right? There are drugs available. There's Lyrica, and there's, duloxetine, and there's amitriptyline, but they're all pretty bad at managing chronic pain. They all work in 1 out of 5 people or so with serious side effects. And so the end game of what I do and what all my colleagues do is ultimately let's try to give people some new options that might work better and or have fewer side effects. And we haven't really had a new drug of that type except for migraine. But migraine excluded, we haven't had a new drug of that type for many decades now.
All right, 10 minutes left. So with emerging technologies, obviously you just said there's no new drugs coming out. Is there anything, and migraine, I get them all the time. It's really horrible. I always hope that there'd be something new.
Well, there is the new CGRP drugs. They're brand new and they work pretty well.
What's the main cause of migraine? I mean, you're a doctor. Can you tell me?
The leading hypothesis at the moment is sensitization of the lining of the brain due to release of neurochemicals like CGRP. Now, why the CGRP is released in people that get migraines, no one has the slightest idea. But in terms of like what causes migraine, that's what people think is going on.
That's interesting. I really like stuff like this. I like a good mystery. I like a good whodunit. Is there anything that's plaguing you right now as far as things that you'd like to be able to figure out, or you're waiting for science to try to figure out?
I'm actually I'm more optimistic than I have been in a long time because there have been amazing technical advances to the point where we can do whatever we want now, right? Like we can go in and we can either turn on or turn off very precise neural circuits. It takes some genetic engineering and it takes, you put in light or you put in certain drugs. But the point is that, looking what we can do now compared to what we had available at the beginning of my career 30 years ago, it's as if we were doing experiments with a mallet at the beginning. And now finally we're able to do experiments with like a laser guided, microscalpel. Like what's available to us in terms of technical ability now is really, really stunning. The problem, of course, is that we've also seen just how complicated it is. I am reminded of Donald Rumsfeld's quote from way back when about known unknowns and unknown unknowns. So what we've done is we've taken a lot of unknown unknowns and we've turned them into known unknowns. Now they're still unknown. There's a lot of work to be done, but you would much rather be in a position where you were trying to explain known unknowns than being surrounded by unknown unknowns. And so I think that's sort of the point in history we are with pain research. And because of that, I'm looking forward over the next 10, 20, 30 years to rapid progress. It hasn't really happened yet, but I really think it's about to.
I think you're right, and I think we're at this moment of it's going to be exponential change for everybody in every field, thanks to the various gizmos and gadgets and AI that we've got created for ourselves. We'll have to cobble this whole thing together. I know it was a rocky start, but you come back and do it again sometime. What do you say?
I'd be happy to. It was fun.
Okay, so Department of Psychology at McGill University, we had Dr. Jeffrey Mogil, wonderful human being, although he's got to give a few mice a few Charlie horses in order to make advancements.
Right.
Anything you want to add before we go?
Not really, but it's been a pleasure talking to you.
All right, we're going to sign off to everybody in TV land. Thanks for coming. We'll see you next time. Bye.
Bye-bye.